Welcome to the promised land, kids. This is combining like terms. That is right. We're getting into the deep stuff right now. I know for some of you, this might just be a review. You probably already skipped it just by the title alone, but please review it. Please do, because you cannot forget about this. Now, how about we just jump right into it? Negative 2x and 3x. This is considered like terms, all right? Why? Because both have a number and both have the same variable and exponent. What you don't see right there on this x, it's an invisible 1 in the exponent place, all right? Every variable has an invisible power of 1, all right? Every exponent. So whenever, or not exponent, every variable does. So x equals x1 and x equals x1. So they're both the same pretty much, right? What's not considered like terms? Let's review something that doesn't look like it's like terms. This is not like terms right here. All right? Yes, they both have numbers. Yes, they both have the same variable, but guess what? They both do not have the same exponent. So, this does not make it like terms. Now, I know what you're saying. Well, Neo, I mean, this one has a negative and this one doesn't, so doesn't that matter also? I'm like, no, it does not, all right? The only thing you ever have to look at whenever you're comparing like terms is if it's the same variable and the same exponent, all right? Number does not matter. Symbol does not matter. This is going to be key, all right? Because the first stuff that you're going to be working on in the worksheet that I have down below for you is just identifying whether it's a like or unlike. So you have to spot this section here and make sure it's identical. Another little quick note. Let's add the 2 on this one. Let me bring this one closer. Is this like terms or unlike terms? Believe it or not, it is like terms. Again, these invisible ones will get you, I promise you. Whenever you have a variable, let me write this in a different color so you can follow along. A variable, any variable, x, y, z, it doesn't matter. Let's avoid x for a brief second. Let's use a. I don't know why. You know what? Screw it. Let's use n for Neil. A variable, a letter basically, will always have an invisible 1 next to it. And believe it or not, an invisible 1 that it's in the exponent place. It's n to the 1 power. I don't know what you call it. I don't know. But there are those invisible ones there. You must always have that in your mind whenever you just have a standard variable just hanging out by itself. So in this specific case, this has a negative 2, and this one, even though you don't see it, does have a 1, right? They both have an x, and they both have a 2. This whole thing is like terms, all right? So you got to identify this, and this is another thing that you got to be a master at, is identifying it alone. Moving on to now actually combining it, all right? Let's throw up a really, really not too long, but long problem up, all right? What we have here is 9x squared minus 3x cubed. I was saying 3 in the last video, and from time to time I will just say 3x3, but that's just for your guys' sake, because I know you guys don't like, you know, long stupid terms being thrown at you, right? So I just make it less complicated by saying 3, but this is considered negative 3x cubed. The power to the third power means cubed, and let's say this was instead of 4, it'll be negative 3x to the fourth power, right? But yes, square, cubed, and everything else is just to the fourth power, to the fifth power, whatever. That's just a little FYI moment. So we got this problem here. Let's combine like terms, right? What do you got to do? You got to first identify what are the like terms, which is what we just learned just 2 seconds ago. How do you identify what are like terms? I like using shapes, you guys, and I want you to use shapes. For instance, I'm going to use circle. I'm going to use a circle for all the terms that look to have a letter with an x squared. So I'm going to go all across here, and I'm going to see which ones look like that. And in this specific case, the one that matches this 9x squared happens to be this negative 2 squared. All right. Now, when you're identifying these terms by using your shapes, check what I did. All right. I actually included the symbol. I did not just circle that. I included this symbol along with it. That's really important because that's going to be how you actually combine it. Because when you combine them, it ended up looking like this as the operation. 9x squared minus 2x squared. All right? The minus. That's the key to identifying what these two are going to combine into. Now, how do you do this operation? Pretty simple, you guys. What's 9 minus 2? It's 7. These x squares, you just throw it on. You don't even bother to do anything with them. It's not tricky. There's nothing that you have to remember. You literally just throw it on, x squared. All right? So, what do I have here now? What I have is 7x squared. Let me go write it brand new. 7x squared. That's what these two has become. They've both been eliminated and transformed, combined into 7x squared. And now I'm just going to get these two, and I haven't really touched them yet, so I'm just going to throw it on to the new term that those other two has become into, which was the 7x squared. So I have this now. So go identify anything else that looks the same. Is there anything else that looks the same? Well, there's no more number with an x squared. Is there any other number with an x cubed? No. Is there any other number with an x next to it? No. These are all not like terms. So guess what? This is the end. That's all you have to do. Except for the one last little step. You know what the last little step is? Is arrangement. You got to arrange this, you guys, in something called standard form. What that means is highest to least. Basically, math wants things always arranged from greatest to least. So in this case, just another little FYI moment. You could have 1 billion trillion as a number. X will always be coming before that number. It's greater than 1 billion trillion. Just one measly little x, or any other variable. You know, A, B, C, D, it doesn't matter, right? What's bigger than that variable? That same variable squared. And what beats that variable squared? Variable cubed. And what beats that variable cubed? That variable with to the 4th power, then after that to the 5th power. Basically, the exponents are keys to indicating which one should come first. All right, that's pretty much all I was getting at. That's important because arrangement is key in your actual final solution. So in this case, the negative 3x cubed is bigger than this positive 7x squared. I threw this positive sign because even though it's not there, it is there. It is a positive 7x squared, right? And then the last step would just to throw in that measly little x, right? Oops, 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 no, what'd I do? Okay, whatever. So this is in reality your final answer. Negative 3x cubed plus 7x squared plus x. All you have to do is arrange. Keep track of those symbols. That's going to be key when you do arrange. All right. Other than that, that's pretty much it with combining like terms. Let's go back a whiles away. Something that you do have to understand is, are these like terms? No. X and a Y, all right? The actual letter itself does matter, all right? It really does matter. It has to, the letter and the exponent has to match identically in order to combine them. How do you combine them? Well, it depends on the operation that you include when you do indicate whether that is a like term. Also, a quick note. There is a little bit of language arts in the math, if you really want to look at it like that, because the alphabet is key whenever you do your last step, which is the arrangement piece, the arranging into standard form, because X might be your lowest number or your lowest term in your final solution. Let's say this was your final solution right here. X squared plus b2 minus y, right? How would you arrange that from highest to smallest? Well, this negative y will be the smallest one because it doesn't have an exponent, right? Now, what would come before that? Both of these happen to have a square in them, right? So which one would you choose? Well, you use the alphabet as the key. A, B. B comes first, way first before X, right? So B, the positive B, would be the first term, and this positive X squared would be the middle term. So then you have b squared, x squared, and then this measly little y hanging out because it doesn't have an exponent. So use the alphabet whenever you have multiple variables in your final solution. Yeah, I think that's it. I think you guys pretty much have it. Remember, always include the symbol whenever you're doing your little shapes to indicate whether they are like terms. Because that symbol is going to be the key of how you combine them. And once again, how do you combine them? You just do the standard operation. You don't worry about the actual variable and the exponent. You just copy that over, all right? Later on with the multiplication, which is going to be possibly our next video, that might be the tricky part because you do have a little trick that you have to deal with the variables. But don't worry about that right now. Just do the worksheet below of combining like terms, which just includes adding and subtracting. That's all combined like terms is. I forgot to mention that from the beginning. Do the worksheet. Ask me for the worksheet if you're on my class. And yeah, hope this is easy. Hope you guys enjoy. And see you on the other side.